All right, so today we are adding our second layer onto quadrilaterals. We know that we have already covered just what is a quadrilateral. So any polygon that has four sides is a quadrilateral. We've talked about the parallelogram. Okay, I'm going to revisit all of those properties in just a moment. And now today we're going to add a layer and talk about a rectangle, rhombus, and square. So plural of rhombus is either rhombi or rhombuses. So we have a choice here when we're talking about plural for rhombus. So down below, I made you just a really good visual where we're looking at our broad category of parallelograms. So here, anything in this box is a parallelogram. Okay, and then we can see that inside we have our rectangle. A rectangle is a parallelogram. It shares all of its properties as well. A rhombus or rhombi, rhombuses, right? Also a type of parallelogram, shares all of its properties as well. And then the square is really all of the above. The square is considered to be a rectangle, a rhombus, and a parallelogram. It shares all of those properties. So a good starting point for us today is to first just revisit what makes something a parallelogram. So here, this part is just meant to be review. So a nice little recap of where we left off. Okay, so a parallelogram is a quadrilateral with two pairs of parallel sides. We know that it's even built into its name, parallelogram. Okay, so we have two pairs of opposite sides congruent, two pairs of opposite angles congruent. So there's one pair, and here is the other pair. Okay, the diagonals bisect each other, and whenever we have a figure that's really just a parallelogram, we have a longer diagonal, right, that's split into two parts that are congruent, and we have a shorter diagonal here that's being split into two congruent parts as well. Okay, we also know that we have four pairs of consecutive angles that are supplementary. We called those angles same side interior. It is the same thing as consecutive. Consecutive just means that inside of our figure, our shape, we're looking at angles that are right next to each other. And remember that that relationship, right, it builds off the parallels. So because I have two pairs of parallel sides, here and here, let's say that I draw in a pair just to help you visualize, here and here, and I view this as my transversal, right, I can see this pair of same side interior angles that are supplementary. And now we're saying, well, let's just call them consecutive. It means the same thing. So then I have the four pairs of consecutive angles that are supplementary. So that would be 1 and 4. Those measures would sum to 180. So would 1 and 2. So would 3 and 4. And so would 4 and 1. Okay, so now we're going to take on the rectangle. So the rectangle, first and foremost, is a parallelogram. So it's going to share all of its properties as well. Let me acknowledge that. Okay, so again, a rectangle is a parallelogram, so it shares all of the parallelogram properties, and then it has two of its own. So all of the interior angles, all four of them, they are all right angles. And that's built into the rectangle's name, right? It has angle right here. So it's telling us that it's the relationship between those four angles. They're all right angles. They're all 90 degrees. Okay, the other thing that we know is that our diagonals are congruent. So this diagonal here is congruent to this diagonal here. And since it's also a parallelogram, the diagonals get bisected, so we end up having this part congruent to this part, and same thing over here. So I'm just going to remind you that we have congruent diagonals and the diagonals bisect each other. So what's fun to point out here is that we end up having a whole bunch of triangles inside that are isosceles. So these two triangles here and here, they're going to be isosceles and congruent, and so will this pair right here. All right, so now we have one of my quadrilateral puzzles. This one has to do with a rectangle. I'm going to mark all of my givens in red. So I'm being told first that PS is 24, PQ is 18, the measure of QPR, so P right there is the vertex, QPR right here, that is given to me as 55 degrees. All right, so now I want to connect the dots, right? I want to connect all of the missing angles and segments. So first thing that I know, since it's a rectangle, is that all of those interior angles, they are right angles. So I can show that box notation all the way around. Okay, I also know that my diagonals bisect each other and that they're congruent. So I know that these parts here, 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 they're going to all be the same, but I don't have the diagonal. I don't have that information. But since I can see a right triangle right here, I know how to solve for it. So I could use Pythagorean theorem, or I could look for a common triple. So what I'm hopeful that we can see is that this is really a 3, 4, 5 with a multiplier applied. So if I reduce both of these down, if I reduce 18 and 24, let's say I divide them both by 6, I can see that this would be 3 and this would be 4. So I can see that it's a 3, 4, 5 with a multiplier of 6. So then 5 times 6 would be 30. I can see that this missing side would be 30. And if you didn't see that, no problem. You could still use Pythagorean theorem to get that information. I'm just trying to give you a few shortcuts built into the skill. So the full diagonal is 30, which means that all of these smaller parts have to be 15. And like I've already pointed out, we have these isosceles triangles that are congruent and this pair as well. So now I need to work on the angles. So if I'm told that this is 55, its complement, right, together they add to 90, its complement has to be 35. Okay, and as I work my way around, remember these are isosceles triangles. So if I look at this one right here up on top, the two legs are 15. So that means that the two base angles would be 35. Okay, for this isosceles triangle, right, the two base angles would both be 55. And as I work my way around, right, if that's 55, its complement would be 35. So I have a 35 here. Base angles are congruent. And then over here and here, they're both going to be 55. Okay, I know that triangles, their angles, their interior angles add to 180. So if these two add to 70, right, what's missing from 180 would be 110. Right, vertical angle of 110. Okay, over here and here, these will both then be 70. All right, so I've connected the dots. I have my angles and segments. So let me write in the answers that I have so far. So, oh, I need my opposite sides. I need one more thing. My opposite sides are congruent. It shares that with the parallelogram. So this would be 18 and this would be 24. And now I've connected all my pieces. All right, so SR here is 18. QR is 24. PR, this diagonals are congruent, so 30. And then PT, so P to T right there is 15. Okay, angles, so I need PRS. So let's see, PRS right there is 55. PRQ here is 35. QPS right there is just 90. QTR right there is 110. Okay, and then I'm asking for the area. So I know that area is pretty simple, just base times height. So I'm looking at what is 24 times 18, and I should get 432. Units are squared. All right, let's flip to the back and let's look at the other two shapes. So I'm looking at my rhombus next. So remember that a rhombus is also a parallelogram. It just has a few more properties of its own as well. So it's going to share the parallelogram properties, but in addition, all four sides are congruent. So I'll give every side a single tick mark. The diagonals are perpendicular. So I'm going to draw a little box notation there. Those angles all the way around, all of these are 90. Okay, and then diagonals bisect angles. So this diagonal bisects this angle and this angle here. And since opposite angles are congruent, right, all of those parts are going to get a single tick mark. All those parts will match. And then the other pair of opposite angles, they're congruent and bisected. So I'm going to give all of these a double tick mark. So what's interesting to note right now is that really what happens with the rhombus is it creates four congruent right triangles. Okay, so that's true for any rhombus. Each of these triangles ends up being congruent. There's the right angle here, 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 and we know that all the sides are going to be congruent as well. Okay, so now my quadrilateral puzzle that deals with a rhombus. So I'm going to mark all of my givens in red. So JML here, I'm telling you is 120. And ML is 10, and that's all I'm giving you, but you actually do have enough to get to all of the other missing parts. Let me show you how. So if it's a rhombus, I know that all of my sides are the same. So all of the sides have to be 10. Okay, if it's a rhombus, I know that the diagonals are perpendicular. So all of these angles here in the middle would be right angles. And I know that diagonals bisect angles. So my opposite angle here would also be 120. And then the 120 split into two congruent parts will give me a 60 here and here, here and here. So building off of that, consecutive angles are supplementary. It shares that with the parallelogram. So these angles here and here would have to be 60 in total. And when I bisect them, I would have a 30 here and here, here and here. So what I snuck into this problem then is a 30, 60, 90 triangle, and that's going to help me solve for my diagonal components. So let's say that I look at this one right here. I could look at any of the four because they're all the same. So if I look at that one where this is 60 and this is 30, remember that the short leg is x, long leg is x root 3, hypotenuse is 2x. And I know my hypotenuse here is 10. So then my short leg is 5, and the long leg is 5 root 3. So that tells me that this is 5, and then this is 5. Right? Diagonals bisect each other. And then this is 5 root 3, and this is 5 root 3. All right, so if I fill in my gaps, I think I have everything I need. I do. So KL here is 10. NK, so NK here is 5. Okay, JN, so JN is 5 root 3. JL, if I add those 5 root 3's together, I have 10 root 3. JNM, so JNM, 90. JKL, the full angle, JKL is 120. MJK, that full angle is 60. JMN, JMN right there is also 60. KLN, KLN right here is 30. Okay, now I'm also asking for the area. So there's a couple ways I could approach it. Since I know that I have these 4 right triangles, I could find this area and then multiply by 4, right? That would be fine. Or I could go through the diagonals, and that's what I'm going to choose to do. Half of diagonal 1 times diagonal 2. So the longer diagonal is this one, so 10 root 3, and then the shorter one right here is 10. So if I multiply across, half of 10 times 10 will get me 50, and then root 3. So my area is 50 root 3 units squared. Okay, and just to remind you, I did a little mini proof in an earlier lecture where I derived that formula just by pointing out that we have this triangle and this triangle that are the same, right? So that's how we derived this formula, by going through the diagonals, right? Each of those diagonals, when we split it, right, it can make the congruent triangles. Or we could, again, look at each of these right triangles and multiply by 4. That's a workaround, right? It's another way we can get to the same end result. All right, last shape is the square. So the square is really all of the above. So it's a type of parallelogram that has the additional properties of a rectangle and a rhombus. So it shares all of those properties. So I just summarized them right here. And then I'm just going to mark the diagram with all of those properties. So we know, since it's a square, opposite sides are parallel and congruent. And since it's a rhombus, all the sides are the same. So I'm going to give a single tick mark all the way around. Okay, I know that my opposite angles are congruent, but since it's also a rectangle, all of these angles are right. Okay, diagonals are congruent and they bisect each other. I know that diagonals are perpendicular also. Okay, diagonals bisect the angles, so if I divide a 90-degree angle, I get a bunch of 45-degree angles here, just like so. Okay, so one more quadrilateral puzzle. We're looking at the square. So all I'm giving you here is one measure. I'm telling you that BD is 20. Okay, so if I build off of that, there's a couple of things I can do. So I know that my diagonals are congruent and they bisect each other. So all of these parts here have to be 10. I know also that all of my interior angles are congruent. They're all right angles. And those angles are getting bisected. So I have 45 degrees in all of these spots. All right, diagonals are perpendicular, so I have a right angle right here. So it looks like I have everything except for my sides. So if I picture one of those right triangles, I can see that my two legs are 10. These are 45 degrees. So I have a 45, 45, 90 or an isosceles right triangle. The two legs are x and the hypotenuse is x root 2. So I know that my hypotenuse would be 10 root 2. So all of my sides will then be 10 root 2. Okay, so next, fill it in. So CE is 20. EF is 10. DC is 10 root 2. BFC is 90. BED here is 90. CDF right here is 45. And then I want area. So area is just base times height. Okay, or a side squared because the base and the height are the same. Or I could go through the diagonals, 1/2 diagonal 1 times diagonal 2. If I drew in an apothem, right, I do 1/2 AP, right? We got some options with the square. So I know each side is 10 root 2, so if I multiply 10 root 2 by itself, that's like saying 10 times 10 times 2, and we get 200 square units. All right, so lastly, I'm going to jump on the coordinate plane. So I'm going to show that quadrilateral GLAM is a rhombus. So if it's a rhombus, I can show a couple of things. Probably easiest to show that the opposite sides are congruent. And not just opposite sides, all of the sides are congruent. So opposite sides because it's a parallelogram, and then since it's further classified as rhombus, we need all the sides to be the same. So when I look at each side and I picture the right triangles, I'm looking right here, for example. So let's say that I look at GL first. I can see that right here, this span is 8 units, and this is 1 unit. So to get to this measure, I need 8 squared plus 1 squared. So 64 plus 1, right, I get root 65 overall. So I could see this right triangle. Let me just sketch that, where this was 8 and this is 1. I was getting the hypotenuse. Now if I look at where AL is, I'm going to see the same triangle, right? No matter how I frame it, I have a leg of 1 and a leg of 8. So AL is going to be the same root 65. And then MA, let's say that I draw that right triangle in 1 unit and 8 units, so same thing, root 65. And then GM, if I draw in that right triangle, right, I'm seeing the same exact thing. So GM would be root 65 as well. So if it's a rhombus, right, I need all 4 sides, not just the opposite ones. I need all 4 of them to be the same, and I've just achieved that. So I could give each side a single tick mark and say, well, they're all root 65. So this is a rhombus because we have 4 congruent sides. They all have a measure of root 65. Okay, one other thing that I could point out is I could go through the diagonals and I could show that my diagonals are perpendicular as well. There are a few other shapes that do have perpendicular diagonals, so I'd have to make sure that I show that it's a parallelogram first. So if I show that it's a parallelogram that has opposite sides parallel and then I have my diagonals perpendicular, then I have a rhombus also. Okay, and then perpendicular in terms of slope, right, I need to show that I have slopes that are opposite reciprocals. All right, lastly here, I need to show that this quadrilateral is a square. So if it's a square, we know that that means that it is a rhombus and a rectangle and a parallelogram. It shares all of those properties. So let's see, what would be easiest? So probably easiest to first look at slope. So let's say that I look at slope of all the sides. So let's say I just go in order. So KR, what is its slope? And then work my way around. So I want this slope, I want RO, I want its slope, I want OC, and KC. Okay, so if I look at slope here, I'm going up 1, 2, 3, and right 1, 2, 3, 4. RO, I'm going down 1, 2, 3, 4, and right 3, so -4/3. OC, so I'm going up 1, 2, 3, and right 4. And then KC, I'm going down 4, right 3. So I've gotten all my slopes, and something I notice is that these slopes here and here are opposite reciprocals, so they must be perpendicular, which is getting me the right angle here, and same with these, and then those. So I have these 4 right angles, right, because my consecutive sides are really perpendicular. Slopes are opposite reciprocals. Okay, and then if I'm looking at, so I know it's a rectangle right now because I know that I have here, again, all the 4 angles are congruent. So I need to show that it's also a rhombus. So I could connect the diagonals and show that the diagonals are perpendicular, or I can show that all my sides are the same. And what I'm seeing with all of those slopes is that I have a series of right triangles where my legs are 3 and 4, right? Here's 3, here's 4, here's 4, here's 3, and so forth. So that's a common triple, and that means that the hypotenuse is all 5. So all of these sides would then have to be 5. All right, so I've done my job, right? I've taken one property from the rectangle. All of the angles are right. They're all 90 degrees. And then one property from the rhombus, which is that all of my sides are congruent. So let me write that. So square, because all angles are congruent, right? They're all right angles. My slopes are opposite reciprocals. And all 4 sides are the same. All sides are congruent. They all have a measure of 5. Okay, so I could also show that my diagonals are congruent and that they're also perpendicular. That would be another way of getting to the same end result. Okay, and I'm just going to reiterate here why I can say perpendicular. Right, perpendicular because we have slopes are opposite reciprocals. So the slopes are opposite reciprocals. Okay, so we know that that means that they're opposite signs, but the fraction gets flipped. All right, that's all I have for today. Have a good rest of your day.